What's up, people? Hello, everyone. How are you all doing? Welcome to today's session. My name is Anoop, and this here is Vedantu 9th and 10th English channel. What is up, people? Long time no see. All the ninth graders. How are you all doing? Yes, it's been so long since I've taken a live session for ninth graders. Welcome, people. Welcome. So, how has it been? How's life? How are your preparations going for your final exams? I'm great, Devida. Thank you for asking. Namaste, Naman. Yes, Sugam. How are you doing? Welcome. Hi, Anjali. I'm great. How are you doing? Good evening, people. Good evening. I hope that all of you guys are doing good. Hi, VCC online classes. Hi, Sanjeev. Hi, Shanvi. What's up? Hi, Gupta. Hello, ma'am. Hi Sharia, how are you doing? Welcome, guys. Thanks a lot. How are you people doing, guys? I hope that all of you guys are doing good and taking care of yourself. And I hope that all of you guys are giving your very best for your exams as well, preparing yourself. Now, again, guys, don't ignore the fact that you might have final exam or might not, but still make sure that you give your 100%. Make sure that you pay attention because nonetheless, it's not going to go to waste. You will be studying all these topics in your higher grades as well. So the better you're prepared, the better it is for your future as well. Alright. So anyways, how you all doing? It's alright, Gupta ji. I'm just making fun of you now. So do you know that scientists prove that students cannot hate on? Oh my god! Netaji, oh my god. I'm so happy. That's one of the best statements that I've heard. Thank you. Good evening, people. Welcome. Hi, Ashmiji. How are you doing? Welcome to today's session, guys. Once again, my name is Anoop, and this here is going to be the second session of work, power, energy. So, in the last session, if you guys remember, we understood the basic concepts of work, power, energy. Today, we'll be understanding about kinetic energy, and we'll also solve some numericals based on that as well. So, are you guys excited? Yes or no? Mentee is there. Mentee is there. For sure, Mentee is there. Towards the end, we'll be doing Mentee as well. I mean, after we study. So just give me like 15-20 minutes. We'll be completing the topic. And then we'll start with Mentee. Alright? Yep. Alright. That's what I'm talking about. Alright. Yes, people. Alright then. Let's get started. Now, let's start the session with a very interesting quote. And the quote is so true for all of us right now. The quote is this: procrastination is the foundation of all disasters. First of all, what is procrastination? For all those who are wondering what that word is, that is nothing but saying that you will do something tomorrow. Pushing it away. Like, what is that? There's the statement, no? Kal kare jo, aaj kare so kal, something like that. I don't know. So, yeah, it's basically like that, guys. Make sure that whatever you're supposed to do it today, because I know that including us, including me, we are all we have all gotten this habit of being comfortable, and we are saying that we'll do it tomorrow, and things are going bad as of now. So make sure, because your exams are approaching, so this is no time for you to lack off. Make sure that you pay attention, and I'm pretty sure that every one of you guys will rock it in your exams. Alright, so yes guys, in the last session, like I was telling you, we had done scientific work and numericals. We understood what exactly is work. In terms of physics, what is work, we've seen that. If you haven't watched that video already, please do make sure that you watch that, because it's a very interesting session, so make sure that you watch that as well. So without wasting any more time, let's get into today's session. But before that, this is your homework. If the angle between the force and displacement is dashed, then work done is said to be 0. The answer to that question, guys, is 90 degrees. So I told you that if, for example, if the displacement is this way and the force is applied in this direction, this is the force and this is the displacement, then in this case, if you remember the formula, work is equal to Fs cos theta. So cos 90 is nothing but, cos 90 is 1. Sorry, 0. Cos 90 is 0. So because of that, guys, you'll get that work done is said to be 0. When the angle between displacement and force is 90 degrees, that is when work is said to be 0. Alright, so that's it, guys. Let's get into today's session. Yeah, alright. Energy. Let's talk about it. Everyone, relax. Okay. The one statement that all of us have told at least once in our life is, I don't have energy to do something. I don't have energy to go for a run. I don't have energy to study right now. I don't have energy to walk. Now, this is one common statement that we use in our day-to-day activity. But what is energy in terms of physics? If you have to define what is energy, how would you define energy? Let's talk about that. Okay, let's take a simple example, guys. Let's say that you're cycling, all right? Now, when you're cycling, in the start, you are well rested, you have eaten. So what do you do is that as soon as you start the race, or as soon as you start cycling, you would bicycle with a very high speed. But can you maintain that speed for 10-20 kilometers? What do you people think in the chat box? Will you be able to maintain that same speed that you started off with for 10-20, maybe even 30 kilometers? Is that possible? Is that humanly? Obviously not, right? Because we're all humans. We are not professional cyclists. Obviously, you will not be able to do that. So what happens? You tend to lose energy, and as the energy inside your body reduces and reduces, your speed also reduces accordingly. So what does this mean? When you have more energy, you do more amount of work. When you have less energy, you do less amount of work. Now this statement is true for pretty much everything. When you're running also, when you're running in the start, you run, you're like full of josh, you're like all pumped up, you're like, you're going to lose 10 kilos in one day, so you start running. And then after some time, after 1 kilometer, 2 kilometer, what happens? You start to get tired. And when you start to get tired, when you start to lose that energy, what happens? You slowly start to jog, and then you walk, and then you crawl, and then you lie down on the floor. So that's what happens, because this is reality. Now, okay, let me ask you another question. How many of you guys have played this game called as GTA, this Grand Theft Auto? How many of you guys have played this game? I don't know. Like when I was a kid, I used to play that game. So I'm asking you, how many of you guys have played? Anyone here who has played this game called as GTA? Now, in that there's this character. So basically, yeah, you've done it, no? You've not done it. Shami, what is this? What are you doing with your life? Now, in this game. So what you do is that in this game, you just run around and then you kill people and all that. Okay, so it's not a good game, but still. Now, in that game also, when you start running, when you hit that sprint button, when you start running, the character does not run forever. After some time, he'll slow down and then he'll start walking. Have you ever noticed that before? He'll start running in the first, then he'll start to jog. Why? Because you lose energy. Now, this is what is energy, guys. Energy is nothing but the capacity to do work. When you have more amount of energy, you do more work. When you have less amount of energy, you do less work. Now, this statement is true for anything that you take. So higher energy means you can do more amount of work. Less amount of energy means you do less amount of work, because energy is what? The capacity to do work. For you to do something, you need to produce energy. You need to, your cells and all that, your mitochondria and all that, about the biochemical process that happens inside your body. It is producing that energy. So more energy, more work. Less energy, less work. That's all. So by this, guys, by using this definition, let us conclude what is energy. Energy is nothing but the capacity to do work. No matter what work you do, you need energy to do that. And that energy that you put in, that is what is defined as energy. In simple words, the energy that you put in to do some work, that is what is energy. Now, the SI unit of energy is same as that of work done. So SI unit of work done is also joules. SI unit of energy is also joules. So if you are asked to define what is 1 joule of energy, 1 joule of energy is nothing but the energy that is required to do 1 joule of work. 1 joule of energy is what? The energy required to do 1 joule of work. Right, people? Is it clear? Did you understand? Did everyone understand what is energy? Is it clear, people? Everyone in the chat box, give me oh yeah, if you understood everything. All good. Yes, that's it, Deshaji. Clear, no? Yes, that's what I'm talking about. Kaboom! That's it. Alright, guys. Okay, now that you've understood this, guys, there are different forms of energy. Now, for example, let me give you an example. When you talk about a fan rotating, can you tell me what type of energy that is? What type of energy that is? When you talk about a fan rotating, or when you talk about a cycle's wheel running, what type of energy do you think that is? Is that mechanical energy? Is it electrical energy, nuclear energy? What? Mechanical energy? Okay, what about, let's say, the light coming out of a bulb? What kind of energy is that? The light coming out of a bulb, what type of energy is that? Obviously, that is also producing energy. No doubt about it. There is energy being produced over there as well. What type of energy is that? Heat energy, yes, absolutely. One more thing is light energy as well. Exactly. So what I'm trying to say is this, guys. Energy can be in different forms. You have mechanical energy, heat energy, chemical energy, electrical energy, light energy, sound energy, nuclear energy, geothermal energy. You have so many varieties of energy. But ultimately, what is the function of all of this? All of this does some amount of work. So if you talk about light, heat energy, basically the energy that transfers from hot object to cold object, that is heat energy. Chemical energy, you already know about that. The energy produced during chemical reaction. Electrical energy is the movement of the electrons, and light energy is nothing but the energy that helps you to see things. Sound energy is what enables you to hear things. But what we are going to deal with is none of these. We are only concerned with mechanical energy. Now, when I talk about mechanical energy, guys, mechanical energy can be of two kinds: potential energy and kinetic energy. So what are these two things? Let me tell you this. See, guys, potential energy is nothing but the energy possessed by a body by the virtue of its position. What do I mean by that? For example, guys, I have this pen right now. If I raise it up, do you think this pen will have some amount of energy? Yes or no? Will this pen have some amount of energy? Because it's, if you compare it to the ground, it is at a certain height. Will it have? Absolutely. This energy, the energy that is possessed by this pen, because of the virtue of its position with comparison to the ground, that energy is what is called as potential energy. Now, do not worry, guys, because I'll be taking a separate session for potential energy for now. Don't worry about it. Next session is going to be only about potential energy. Let's now talk about kinetic energy. Alright, let's understand about kinetic energy. Now again, what is potential energy? The energy possessed by the body by the virtue of its position, by the virtue of its configuration. That is what is potential energy. For example, when you raise up an axe, the axe is at a certain height from the ground. So that is the energy that is possessed by that body. That is what is its potential energy. But let's talk about kinetic energy, right? Because we are here to learn about kinetic energy. Kinetic energy is nothing but the energy possessed by the body when it's in motion. Okay, guys, think about it. For example, if there's a car coming towards you, all right? Let's say that, let's not take a car. Let's say that there's a ball coming towards you and you're standing still. If the ball comes and hits you, will there be some amount of pain that you experience? Yes or no? Would you experience some amount of pain or not? If the ball comes and hits you, would you experience some amount of pain? Absolutely yes. Now, if you want to stop that ball, what would you do? You would move behind and basically, like for example, when a keeper is catching a ball, have you ever noticed that they actually move their hand along with the ball? They go behind, they basically take the ball, they don't just stop it like that, they move along with the ball. Now, obviously there is some amount of energy in that. There is energy possessed in that ball. That energy possessed by the virtue of motion when a body is moving, that is what is called as kinetic energy. Now, let's understand this. What exactly is kinetic energy? How do you define kinetic energy? Now guys, let's take an example. Let's say that there is an inclined plane and there's a car at the top of it. Now, when the car is over here, it has potential energy. Yes or no? First of all, it has potential energy because it is at a certain height h from the ground, so it has potential energy. As it leaves, as it starts to move, that potential energy gets converted to kinetic energy. Why? Because the car is moving. So what happens? That potential energy slowly starts to convert to kinetic energy and it starts to move. And let's say that there is a box at the bottom. All right, it's standing still. If the car comes and hits that box, the box will start to move. Why? Because there is a transfer of energy happening between the car and that of the box. Yes or no? Do you agree with me? There is an energy transfer happening between the car and the box. Yes or no? First of all, are you able to understand the scenario? Yes, the car is coming, hitting the box. So there is the energy transfer happening between the box and the car. So what happens is that there is some work done on this box. So what happened? The box will displace. It will get displaced to a certain distance. So there's some amount of work done, because if you remember what is work done? Work done is equal to force into displacement. So there is some displacement happening, and so I can say for a fact that there is some amount of work done. Simple. Now, let's say that the speed of the car is a little less now. So what will happen? It will still move, but this time the displacement is going to be less. Now what you have to understand is this, people, when the velocity of the car is more, like in this case, when the car is going at really high speed, what happens? The displacement is going to be more. When the velocity is less, the displacement is going to be less. So what does that implicate? That implicates that when the velocity is more, when the kinetic energy is more amount of work is done. When the kinetic energy is less amount of work is done. In other words, when the velocity is more amount of kinetic energy, the body possesses more amount of kinetic energy. When the velocity is less, it possesses less amount of kinetic energy. Are you able to understand this, people? Is it clear so far? Are you able to understand? As in case kinetic energy has more, exactly now. So because it has more amount of kinetic energy, more amount of work is done. Because in the second case, it has less amount of kinetic energy, less amount of work is done. Simple. Alright, now This is one condition. What is it? More is the velocity, more is the kinetic energy. Simple. It's directly proportional. More greater the velocity, greater the kinetic energy. Let's take another example. Let's say there's a truck, alright, and there's a bicycle, and there's a box. Now, if the truck and bicycle, both of them are going at 20 meters per second. Let's say that both of them have the same speed, so they're both going at 20 meters per second. Now, let's say instead of the box, you are standing in front of it. Alright, instead of the box, you're the one standing. Which of these would produce more pain? Which of these will give you more pain? The truck or the bicycle? Which of these will give you more pain? Think about it, guys. Think about it. Once again, Sanju, let's answer that. Do you have Jordans or what? So do you have Jordans? No, I don't. Truck, absolutely 100% truck. Why truck? Because the mass of the truck is way more greater than that of a bicycle. Obviously, the truck is massive, so obviously it will crush you. It will basically produce more pain. Whereas a bicycle, which is of the same velocity, will produce lesser, or basically it will cause lesser pain, or less amount of work is done on you. Why? Because the mass of the body is less. What I'm trying to say is this, guys. When the mass of a body is more, kinetic energy is more. That means it can do more amount of work. So kinetic energy is directly proportional to mass. Kinetic energy is directly proportional to what? It is also directly proportional to your velocity as well. So velocity and mass, both of these, you can say that kinetic energy is directly proportional to both of these factors. Alright, did you understand this, people? Did you understand this? Exactly. Obviously, if a truck hits you, obviously you're gonna get smashed. That's true. You'll become a smashed potato. But you get it, no? Got the answer, people? Got it? Everyone understood? Now, guys. Now what I'm going to talk about is the mathematical expression of kinetic energy. This is the last topic, alright? Listen carefully, because what I'm going to do right now is I'm going to show you the derivation which would come for either 3 mark or 5 mark. So listen very, very carefully, alright? Listen carefully. Let's say there is a ball, alright, which has a mass m, and the ball is moving, it is supposed to move from A to B. Let's say the initial velocity is 0 because it is in the state of rest, it is not moving at all, so the initial velocity is 0. Let's say I apply a force F. Alright, I don't know the magnitude of force, I'm applying a force F. So what would happen when I apply a force? The ball would start to roll down, and what happens is it will come to this position and then stop. Alright, so let's say the final velocity is V. The final velocity is V. And initial velocity is 0. Initial velocity U is 0, final velocity is V. Alright, so far so good. I'm applying a force F. So the displacement that the ball has done, let's say that it is S. Displacement that the ball has done is nothing but S. Now, listen carefully, guys. Here, what is happening? Because there is work done, I can see that it is equal to the kinetic energy possessed by the ball. Because obviously, you need to, basically there should be some energy to do work. So here, I can measure the amount of work done by saying that it is equal to the kinetic energy possessed by the body. Yes or no, people? Are you able to understand the statement? Give me a quick yes in the chat box if you are able to understand the statement. Once again, because there is work done, I can say that that amount of work done is equal to the kinetic energy possessed by the body, because the energy is what? The capacity to do work. I can say that it is equal to the work done. Alright, now listen carefully, guys. Alright, work done, we already know, is nothing but force into displacement. This is something that we've already seen in the past session. Now, according to Newton's law, according to Newton's second law of motion, we know that force is equal to mass into acceleration, or mass times acceleration. We already know this as well. Now, I know what is the force, but I know what is the displacement. So what I'm going to do is, I am going to use the third equation of motion. So what is the third equation of motion, people? Anyone who remembers this? Anyone who remembers the third equation of motion? Alright, got it. Anyone who remembers the third equation of motion? Which is the third equation of motion? Why do you hate Newton? Newton is a good guy. He was trying to help us. So which is the third equation of motion? All I say is Baiju OP. Good to know. Alright, anyone? Nobody? Alright, anyways, the third equation of motion, because nobody is able to answer, is nothing but V square is equal to U square plus 2AS. This is the third equation of motion. So from this equation, I am going to get what is S. So how do you do it? S is equal to V square minus U square divided by 2A. Simple. Rearrange the equation, simple arithmetics. I got this. What I'm going to do is, let's say this is equation number 1, this is equation number 2, and this is equation number 3. What I'm going to do is I am going to apply equation number 1 and 2 in A. Alright, I'm going to apply the first, second and the third equation. Basically, I'm going to apply, substitute the values of F and the value of S in the first equation. That's what I'm going to do. So what is it? So from the first equation, I know that force is equal to, so work done, or basically work done, I can write work done is equal to kinetic energy. I've already stated that. So I'll write it as kinetic energy. Instead of work done, I'll write it as kinetic energy because I've already stated that the work done is equal to kinetic energy possessed by the body. So kinetic energy is equal to what? Is equal to force times displacement. Force is equal to mass into acceleration, and displacement is equal to v square minus u square divided by 2as. Now, sorry, 2a, right? It's 2a. Awesome. Okay. Now what I'm going to do is, guys, I'm going to simplify this equation. So when you simplify this equation, a gets cancelled. So what you're left with, you will get it as kinetic energy is equal to m into v square minus u square divided by 2. Now, if you remember the start of the equation, I told you that the initial velocity of the body is 0. U is 0. So in place of u, I am going to substitute u is equal to 0. So I'm just going to substitute the value over here. So what will I get? M into v square minus 0 divided by 2. So this is the equation of your kinetic energy. So what is kinetic energy? Kinetic energy is equal to half mv square. That's all. This is a simple 5-mark question. Did everyone understand this, people? Is it clear? Did everyone understand this? Is it clear? Understood? Sure, I'll check it out now because I still haven't got the chance to solve it. Guys, any doubts that I've missed out? Is it clear, people? All good? So this is the derivation, guys. This is a 5-mark derivation, easy derivation. All you need to do is remember 3 things. Work done is equal to force and displacement. We know that work done is equal to the kinetic energy because energy is nothing but the capacity to do work. So if you want to measure that, I can measure it in terms of energy as well. And we know that force is equal to mass times acceleration. Displacement, I'm going to use the third equation of motion. V square is equal to u square plus 2as, and basically solve for s. Once I solve for s, I'll substitute the value of s and the value of f as well, force. So I'll basically, so I don't derive, what to say, substitute the values, simplify the equation, I'll get us k is equal to half mv square. Simple. That's all. That's all. So that is a 5-mark question, people. That is pretty much it for the learning part. We will get into the Mentee now. But before I get into the Mentee, people, if you want to have more such amazing sessions and have a lot of fun and also score 101% mark, all you have to do is click on the link that is given in the description as well as in the comment section below. Once you click on this link, people, you're going to open a whole world of online learning wherein you have the best of the best teachers with unlimited live classes every single day with the highest level of quizzes and leaderboards for every single session. So you never miss out on anything that is fun, and you never miss out on the important things that is, what you learn in the session as well. Apart from this, you get to compete with the rest of the world and check where you're really at, not just with your state, not just with the country, but the entire world, because you'll have students from all over the world and you can actually compete yourself and see where you're at and how good you are at the subject. Apart from this, you can download all the premium content of every single session and watch every single session with the interactive replay, because live sessions are going on 24/7 and it's not possible for us to watch all attend every single session. It's not possible for us, but still, guys, do not worry, people, because you can still take part in the quiz and get the leaderboards with the help of the interactive replay. So you can, when you're watching the recording, you can still take part in the quiz and see where you would be at if you had the leaderboard, if you were in the session as well, and download all the premium content with the handwritten note of every single teacher. In fact, the handwritten note of every single session would be there in the description as well, guys, so you never miss out on that as well. With that, the best part, if you ask me, is that you will get your doubts cleared inside the class. Not just that we will have the master teacher, but you'll have another teacher with you called as the class teacher to help you clear every single doubt. So you never miss out on any doubts and you're basically in safe hands. With all of these things that I just told you, together with all of that, you have 5,000 plus micro courses and crash courses all for free of cost. Again, the link is given in the description. all you have to do is enroll into this pro subscription course, and all of this would be yours. You're getting a lot more for a lot less. And the coupon code, my coupon code is AME Pro to get your discounts. So you have the base price of the, if you go for the 1 month program, the base price of that is 2,699. But if you use the coupon code, you get a discount of about 500 rupees, and what you'll be paying is around 2,159. If you go for the 3 month program, the base price of that is around somewhere around 6,999. You get a discount of 1,500, and what you'll be essentially paying is 5,599. Again, the coupon code is AME Pro. So once you enroll into the session, guys, think about it. In 1 month, a student would have roughly attended about 200 sessions on a minimum of 200 sessions. So if you have attended 200 sessions, a minimum of 200 sessions, what you're essentially paying is just 11 rupees per session. If you go for the 3 month program, again, you attended about 600 sessions because 200 sessions per month, but that is the minimum number. You can go up to 300, 400, totally up to you guys. So if you go for the 3 month program, 600 sessions in 3 months, you would roughly have paid 9 rupees per session, which is less than what you pay every single day to get a packet of lace. Alright guys, so again, the link is given in the description. It is for your own future. Trust me guys, you would find it super duper helpful, and the coupon code is AME Pro to avail your discounts. Alright, so that's it guys. Let us now get into the Mentee. I know all of you guys would be waiting for this, so let's get into the Mentee meter quickly. Join the Mentee meter guys, www.mentee.com, and enter the code 5900915. That is the code for today. Quickly join it and then let me know. In the meantime, let me clear your doubts. You can, Tana. You can still join the micro courses. Yes, you can now. Yes, you can. So because I don't know, Newton was eating apple with a day. Kirti. Work and energy are seen as the same numerical and even has the same formula for displacement and Newton's rules. But is there no difference between them theoretically? Theoretically, there is some difference, Sanju. Theoretically, there is some difference. See, energy is the capacity to do work. Energy is the capacity to do work. Work is when the force applied, creates some displacement. That is what is work. When the force is, for example, I could push this wall. I'll feel tired. I'll lose energy. But I cannot say that work is done. Why? Because there is no displacement. So you could be spending energy and still have zero work done. You could be spending all your energy. See, for example, if I stand the whole day and try to push the wall, I'll start to sweat. I'll lose energy. I'll feel hungry. But can I say work is done? No, because there is no displacement happening. So when you talk about in terms of physics, work is done only when there's displacement, and energy is nothing but the capacity to do work. How much amount of, basically, for you to do that, for you to push that, you have to spend some energy. That energy that you spend is what, okay, that thing that you do, that is what is energy. All right, that's all. Code is 5900915. You can see that in the top corner, right? Top corner, 5900915. All right. Yes, people, I'm going to start the quiz now. All right. Okay then. So the first question for the day, 4 questions back to back. You get 10 seconds to read the question and then 30 seconds to answer depending on the question. Here's the first question. An object that does work gains energy, loses energy, no change in energy, or can't say, sorry. An object that does work gains energy, loses energy, no change in energy, or can't say at all. Think about it guys, think about it. Sir, unmute doubt. Yeah, dash me, why not? Alright, yeah, high five, legendary, high five. So is kinetic energy 0 at highest points? Yes, legendary, yes. At the highest point, yes, the kinetic energy is going to be 0 and potential energy is going to be maximum. And at the lowest point, just before it's going to hit the ground, at that time, potential energy is going to be 0 and kinetic energy is going to be maximum. Awesome guys, well done. An object that does work obviously loses energy. You know, when you're doing some work, you're losing energy. Remember, higher energy means more amount of work. You're losing energy when you're doing some work, right? It's not gaining energy, you're losing energy. When you're doing some work, you're losing energy, not gaining energy, people. Alright? You're losing energy. Nonetheless, that's the first question. It's okay. I understand that you guys have to warm up a little, so it's alright. Avinash was the first answer, followed by Omkar. I will win. Good to know, buddy. Then it's Vroom, Mohit, Bhumika, Shah Bhumika, I'll answer your email. Shaurya, Mahi, Panavjeet, Praneet, and Amlan. Congratulations, people. Congratulations. That's the first question. Moving on to the second question for the day, guys. Here is your second question. Take a look at this one. The question is, when the kinetic energy of an object of mass 10 kg moving with a velocity 1 meter per second, Okay, what is the kinetic energy of a body of mass 10 kg moving with a velocity of 1 meter per second? Very simple question, people. 1 minute you had, your 1 minute is it 10 joules, is it 20 joules, 5 joules, or 15 joules? Very, very simple question. Oh, is it? Awesome, Ashmi. Awesome. Enjoy your school love. So you're from college or for aeronautical? No, not aeronautical. I did aerospace. Not aeronautical, aerospace. I mean, it's very close, but then it's a little different. A little different. Alright, what do you I did aerospace. Yeah, come on, guys. Let me know what is the answer. Is it mid-put? Check the answer now. Check the answer. Alright. Another 20 seconds. Very simple question, guys. Direct substitution now. Direct substitution and you get the answer. Which one? You mean the college? I did it from Alliance College of Engineering and Design. No? Alliance College of Engineering and Design. Yeah. Oh, thank you. Thank you, legendary. Thank you. Much appreciated. All right, 3 more seconds, people. And yeah, all those who have just joined right now, quickly join the Mentee meetup. We've only done 2 questions. The code for today is 5900915. Quickly join the people. 25 of you guys were able to, almost 25 of the 24 of you guys got the right answer. Out of 40, that's not bad at all. 11 of you guys went to the option number A. Very simple question, guys. If you ask me, this is like probably one of the most simplest questions that you'll be asked. Okay, one second, guys. Let me just close this. So we know that kinetic energy is equal to half mv square. That's the formula. Mass is given as 10. Velocity is 1. 1 square is 1. 2 5s are 10. 5 joules. Simple. That's all. That's all. All right. Simple question, guys. Direct answer. I mean, that is as simple as it gets, guys. That maths is as simple as it gets. Direct answer. Nonetheless, here's your leaderboard once again. Avinash still on top, I believe. Jai Shri Harsh. Oh, like Jai Shri Harsh. Fastest to answer because Jai Shri Harsh. Followed by Shaurya, that is Bhumika. Soumya, Praneeth, Mohit, Amlan, Gayatri, Gopika, and Palak. High five, buddy. Well done, guys. Well done. Beautiful, beautiful looking leaderboard. Very tight competition. I don't see much difference at all. Moving on to the third question. One question can change everything. Here is another problem for you people. Take a look at this one. The question is, two bodies of equal masses move with a uniform velocity v and 3v respectively. Find the ratio of their kinetic energy. Is it 1:3, 3:1, 1:9, or 9:1? Very simple question, guys. Trust me, it's super easy. 10 seconds. That is all you need to solve this question. But read it carefully. Two bodies of equal mass move with a uniform velocity v and 3v respectively. Find the ratio of their kinetic energy. That is the question. Go for it. Come on. Abhishek sir and Mentee, is it correct? Because yeah, the thing is that no, the content is made by one person. So Agita ma'am makes content for both of us. So the questions will be similar because it's the same content. Can't help it. That's all. Let me know the answer, guys. Come on. Quickly. That's tsunami of response, guys. It's all right. Anyways, guys, please do not forget to hit the like button. What is happening? Hey, Ashmi, don't remind me of that. I actually, you know what? I was actually, planning to put up the photo of the last quiz in the stories, and the YouTube manager was like, "Are you sure you want to put it?" I'm like, "No, let's leave it," because I did not see the name. But nonetheless, guys, 20 of you guys were able to give the right answer. Congratulations again, half the class. It is rather disappointing. It's rather disappointing. It's a very simple question, guys. Think about it. All right, let's say that the kinetic energy of the first body is half m. Mass of the body, both the bodies are same. Mv, all right, half mv square. Right, that is the mass of the first body. Mass of the kinetic energy of the second body, let's say, is half m 3v square. So k1 by k2 is what? You're supposed to find out the ratio. So k1 by k2 is what? Half mv square divided by half m. 3 3s are 9, 9v square. So half gets cancelled, mm gets cancelled. So what are you left with? 1v square divided by 9v square, or v square by 9v square. So what is the ratio? 1:9. Simple now. Simple question is, like I told you, you just have to find out the ratio. This is for you guys. I wrote it. You can directly write this step and still get the answer. Directly write that step and get the answer. Very simple question, guys. Very simple question. Very simple question. Now, what is it? Simple. Again, half mv square is what? See, only the velocity is changing. This is the velocity of the first body. This is the velocity of the second body. So all you have to do is compare the ratio. No, you have to. What is the ratio? You have to divide the kinetic energy of the first body divide by the kinetic of the second body. So when you divide it, you'll get it as what? Half mv square divided by half m 9v square, because 3 square 3v the whole square. No, 3 square is 9 and v square. That's all. All right. Now 1:9. That's all, people. Very simple question. Now very simple question. It's okay. Nonetheless, here's the leaderboard once again. Avinash G unfortunately chose the wrong answer, I think he did not say Jai Shri Harsh this time. Sorry, Avinash, because that he goes to the 8th position. Praneeth was the fastest answer to goes to the first, more than the second, Palak in the third, Gopika in the fourth, Soumya in the fifth, Sneha in the sixth. High five, Kavya, Avinash, video on reading heft properly. Okay, Riaz as well. Congratulations, well done, people, well done. With that said, the last question, one of the most interesting questions again. This is your last question regarding kinetic energy. Go for it. Let me know what is the answer. An object of mass m and velocity v has kinetic energy of 200 joules. Find the new kinetic energy if the mass of the object becomes double and the velocity still remains the same. This time the mass is changing. What do you think would be the kinetic energy of the second body? That is the question. The mass of an object m and velocity v has kinetic energy 200 joules. Find the new kinetic energy if the mass of the object becomes double and the velocity still remains the same. Your options are 200 joules, 100 joules, 400 joules or 500 joules. Again, a very, very simple question, guys. But again, it's a little twisted, but it's simple. Go for it. Let me know what is the answer. With Abhishek said, oh, no, Ashmi. No. So like button is power. I would hit it. It's all. Anyways, welcome, guys. Welcome once again. What's your favorite color? Black. That's a black is not even a color, but still like black. According to physics, black is not a color. 27 of you guys were able to give the right answer. Congratulations, people. Beautifully done. Absolutely correct. I'm proud of you guys. Now that is actually astonishing. All right. So let me help you out to solve this question. Kinetic energy is equal to half mv squared. All right. Now you're supposed to find out what is the new kinetic energy. So I'll get it as Ke dash, and the mass of the kinetic energy is 2m for the second one. The when it's doubled up, no. So the new mass is equal to 2m v squared. Simple. Now this is equal to 200 joules. Kinetic energy of the first body, that is half mv squared, is equal to 200 joules. We already know that because that is what is stated over here. Kinetic energy is equal to 200 joules. Now Ke dash is equal to half. You can say that it's half mv square into 2. Half mv square into 2 because I am just taking the 2 outside. What is half mv square? Half mv square is what? 200. We've already stated that is the kinetic energy of the first body. So Ke dash, that is the new kinetic energy, is equal to 200 into 2, which is nothing but 400 joules. Simple people. Exactly. So velocity is double, so kinetic energy will be double. No doubt. Here they've told velocity remains the same, the mass is getting doubled. If the velocity gets doubled, then what would happen? If the velocity gets doubled, it'll become it'll become 4 times. No, because it's v square. It'll become 4 times. Kinetic energy will become 4 times. Here they're talking about the mass. Mass is getting doubled, but the velocity remains the same. Alright, guys. Again, you want me to explain it again? Simple. Once again, kinetic energy of the first body is half mv square. They have told you that the kinetic energy of the first body of mass m, velocity v is 200 joules. So this is basically 200 joules, the kinetic energy of the first body. They are asking you what would be the change in kinetic energy if the mass of the body from m, it becomes 2m, twice, it'll become 2 times the mass, so double the mass. So it'll be 2m. So in 2m v square, it will be 2m v square. Now what I'm going to do is I'm just going to write it as half mv square and I'll take the 2 outside. But so I'll just take the 2 outside. Don't cancel, I'll just take the 2 outside. Because half mv square is what? 200 joules. We have already stated that from the first equation we know that half mv square is 200 joules. So it will become what? 2 into 200 joules. So what will it be? 400 joules. Simple. That's all. Simple. Did you understand it now? Now is it clear, people? That's all, guys. That's explain again now. Okay, once again. Half mv square is the kinetic energy of the first body, which they have told us 200 joules. Simple. They have told you that the kinetic energy is 200 joules. They are asking you what would be the change in kinetic energy if the mass is doubled. So mass, that is m, will become 2m, 2 times, because it's getting doubled. So in the equation, what will be the new equation be? Half 2mv square, because the mass is getting doubled. Now, what I'm going to do is I am going to rearrange the equation such a way that I will get this equation. So I know that half m2, what I'll do is I'll take the 2 outside. So what I'll get? 2 is equal to 2 into half mv square. Now we know that half mv square is equal to 200 joules. We've already stated that from the first equation. So you just substitute the value of, in place of half mv square, you will substitute it as 200 joules. Multiply that with 2, you'll get it as 400 joules. That's all. Simple. Yeah, that's all. I know, right? Again and again, I'll get it exactly. So, anyways, guys, that's all for today. That is all for the last quiz time as well. And here is your final leaderboard for today, people. All right, I don't know what happened to the this thing. Can you guys see me? All right. All right. Anyways, this is the final leaderboard. Praneeth is the winner for today. Congratulations, Praneeth. Follow me more. Then it's Soumya. Then it's Sneha Gopika. I think it's Jai Shri Ram. Then it's Aniket. Omkar, Palak, and Amlan. Congratulations. Congratulations. Well done. So let me just take a screenshot of this one. That is it for today, people. That is all I had to teach. Now is the time for you to ask me whatever doubts you have. I have completed the topic for today. Again, the link is given in the description below to enroll into the courses, and this is your homework for today, people. Let me know what is the answer in the comment section below, so by the start of the next session I can put up your names in the upcoming session. The question is this: a man is transporting a trolley of mass 6 kg and having a kinetic energy of 40 joules. Compute the velocity with which he's running. So you're supposed to calculate what is the velocity. Simple. They've given you the mass, they've given you the kinetic energy. Find out what is the velocity of the body. Let me know what is the answer in the comment section below. Do not send me the answer right now, but in the comment section below, let me know what is the answer. And do not forget to like this. We have 59 likes. That's all, people. Let's hit it. Let's hit 100. 100 should be our target. So that's it, people. That is all from my side. Again, the NTSE link is right here. You can pause the video and take a look at this as well. So this, you get a 90% discount on this. So you can take a look at that as well, guys. And again, the link for the pro subscription course is given in the description as well as in the pinned comment section, and the coupon code is AMEPRO. And that is all from my side. If you want to reach out to me personally, you can also reach out to me at anoop.manon@vedantu.com. Whatever doubts you have, this is the time for you to put it down. I'll try to clear as many doubts as I possibly can. Yeah. So combined session with Abhishek sir. All right, sure. Okay, what is that? Shizuka ji, what's up? Where are you from? I'm from Bangalore. Sure. Soon we'll have a session with Abhishek sir. Soon we will have it. Very soon. Alright, sir. Daya kab aayega? What is it? Daya kab aayega? It says aayegi. What Daya da? Daya is in CID right now. Daya darwaza thod do. He's in CID. What will he do here? Anyways, what door is there to break over here? And show your college's name. My college name is Alliance College of Engineering. Alliance College of Engineering and Design. This is my college name. Yeah, that's all. Anyways, do I know any Telugu actors? Yeah, I know Prabhas. Prabhas is a Telugu actor, no? I know Chiranjeevi. Yeah. Alright, that's all, guys. That's all. I can't understand your language. I know, sir. You know, like, which language are you talking about? English? All right. Okay, I'll try to change the way I speak. All right. What is my age? That's a secret. That is a secret. Love you guys too. So the object is still. Will it possess potential energy? If it is still at a certain height. See, the formula of potential energy is given as mgh, m into g into h, which is mass into acceleration due to gravity into the height of the body. So if it is a certain height. If it is at a certain height, so what is potential energy? The energy possessed by the body at a certain height. If it's on the ground, if this is the ground and the body is on it, then the height from the ground is 0. So potential energy is going to be 0. But if it's a certain height, that is when you say that potential energy is going to be, it possesses potential energy. It should be at a certain height. All right. Hair color is also black. Oh yes, the black is amazing. If I open up my wardrobe, no, all I see is black. I have to touch. Okay, this is not the cloth that I'm looking for. So yeah, that's how it is. What is Fleming's left-hand rule? We'll study about that, Utkarsh, because we'll be starting off with electricity soon. Right now, guys, ask me doubts related to work, power, energy, because all those who are watching the recording later, they should not find it not helpful. That's fine. All right. So whatever doubts you have, you can always reach out to me on this email ID. But yes, we will be starting with electricity pretty soon. I'll be teaching about Fleming's right-hand rule, left-hand rule, thumb rule. Everything will be starting when we start with electricity. All right. So don't worry about that. All right. So your favorite subject after physics, sir? After physics, I've never thought of it. I don't have a second favorite. Okay, wait. I think I'll go with English. I don't know. English. I like social studies because I like listening to stories. But yeah, that's pretty much it. But I can't remember the names and dates and all. But I like listening to stories. That's all. Yeah. David, I'll look into your question. I have asked teacher, like one of the teachers for help. So don't worry, I'll help you out on that. Don't worry, right? Thank you, Snehaji. Thank you. But electricity is deleted. No, no, no. No, Virendra. No, no, no. How is electricity deleted? 10th grade has it. 10th grade has electricity. What are you talking about? How is it deleted? It's a very important chapter. So how is power related to potential difference? How is power related to potential difference? You're talking about electricity again. If I was, like I told you now, all that electricity related question, I've just started off the topic electricity. By 1 or 2 weeks, we'll be completing the topic. We'll be completing everything related to electricity. So I think you'll get all your answers in that. So make sure that you subscribe and be ready for that, because obviously I cannot explain something out of the topic right now. So ask me questions related to the topic, people, so that we can make it as helpful as possible for other people who are watching the session. All right. New word for Malayalam. What word today? So you've covered electricity for CBSE earlier. No, Siddhant. We'll be doing it right now, because I've just started off with electricity just now. I completed magnetic effect of electric current, but we have not started off with we have done magnetism, but we have not done electricity. So I'll be starting off with electricity pretty soon. All right. We've already started off. I think we have done one session, but I'll be doing the rest of it. All right. So if an object is dropped on or free falling, then sir, where will be the kinetic energy maximum, and at the bottom or the top? Just before it hits the ground, kinetic energy is going to be maximum. At the maximum height, kinetic energy is 0, potential energy is maximum. Alright, so at the maximum height, potential energy is max, kinetic energy is 0. Just before it's about to hit the ground, kinetic energy is max, potential energy is almost nil. Potential energy is minimum. Alright, that is the answer. Is it? Arre, Bhavita ji, congratulations. Awesome, awesome. Already you've done the homework. Beautiful. Oh, Shreya ji also. Arre, awesome. So your question enough for NTSC, sir? Is your question enough for NTSC? No, Bhumika, for NTSC, though, you'll have to, prepare a little bit more, because you can expect higher order thinking, like higher order questions and all that, not just the questions that comes from your NCERT. So you'll have to prepare a little bit more. So look for some, competitive books and all that. You will get NCERT textbooks where you can prepare. You'll get all those higher level questions, because you can expect questions from 1 grade above when you talk about your, NTSCs and all that. So make sure that you prepare. If you're very serious about it, then make sure that you prepare properly for that. All right. Anything else done? Awesome, Sejal. Awesome. Regarding NCERT properly, sure. I'm just having a session. It's all right. Kirti, no, it's all right. No questions are ever stupid. It's okay. Your VIP series, yeah. I am itself VIP. No, what do you want VIP series and all? I am a VIP. Sitting here, no. VIP sitting here, no. Sure. I'll make it. Okay. For sure, that's actually a good idea. A video on and how to read your NCERT better. No, for sure. I'll make that. All right. Yeah, Ashmiji, I know, right? Black is awesome. Black is awesome. Alright, guys. Anyways, so that is it. I don't see any more doubts. Let me know what is the answer in the comment section as well, guys, so that I can put up your names in the next session at least. So make sure that you comment the answer. If you want, if you can write on the steps as well. Comment the answer in the comment section below. Put on the answer in the comment section below, so that I can put up your names in the start of the next session. Alright. So that is it from my side. Thank you once again for joining. So still haven't completed syllabus. No, Chandri. By the end of December, we'll be completing the chapter. Alright. All the syllabus will be completed by the end of December. By Jan, we'll start with the revision. And we'll make sure that everything is done by the end of Feb. So don't worry, everything is on track. We'll make sure that it happens, right? When a body is free falling, then at the bottom height would be maximum. So sir, how would potential energy be 0 at bottom? Because the height from the ground is almost very little, no? See this. The formula for potential is mgh. When you're just above the ground, the height is bare minimum, no? Height is bare minimum. Compared to over here, the height is maximum. When it's just about at the ground, the height is minimum. So obviously, if height is less, potential energy is also going to be less. No, it's directly proportional. Getting it? But don't worry, we'll be starting about potential energy in the next session. Alright? I hope you understand this. So if an object is dropped from freely falling, then where will be the kinetic energy maximum? Kinetic energy will be maximum just when it's about to hit the ground. Alright? So the bottommost or at the top? At the bottommost. Alright? At top, kinetic energy is going to be 0. Again. Pre-board is going to start from Jan 4th. Alright, Anushi, that's interesting. But don't worry, everything will be done before your finals. Though we would have completed one round of revision for sure, and then we'll whatever doubts you have, I'll take up separate session for doubt sessions as well. So don't worry. All right. Formula sheet also. All right, Kirti ji. Sure. Please open comment section fast. All right, I'll check it out. Don't worry. Anyways, guys, so that's all from now. For now, thank you for joining once again. I'll see you guys tomorrow. Tomorrow again, I'll be coming live for ICC students at 4:45. So I'll see you then. Current electricity is the chapter. So I'll see you guys then, people. Until the next time we meet, take care of yourself, stay safe, and bye bye. Take care, people. Bye bye. See you all for now. So why do you love Hindi? I love Hindi now, but then my Hindi is bad. That's all. When you're bad at something, you don't try it. That's what I do. So yeah, either I have to be really good at something, or else I don't try it at all. That's how I go. So yeah. Anyways, bye for now, guys. Thank you for joining once again. See you guys soon. Do not forget to hit the like button, and do not forget to subscribe to the channel as well, so that you are notified of all the sessions that comes ahead. Thank you for joining. See you guys soon. Take care of yourself. And if you have any suggestions, people, let me know in the comment section below. If there's any topic that you want to explain better, or anything that you want to talk to me personally about, you can always reach out to me on this email ID. I know at least once in a week I'll try my best to reply to your emails, guys. I'll make sure that I do that. All right. So see you for now. Take care of yourself. I'll catch you guys next time. Peace out, people. Bye. See you all. Take care. Bye.